Okay, so let's talk about this review problem. A random variable x has the probability density function x cubed plus 5 over x over 40 if x is between 1 and 3. Part 1 is to simply verify that this is indeed a probability density function. To determine that it's a probability density function, there are two things we need to check: that the function is always positive, and furthermore, that the integral is equal to 1. Well, let's see. Clearly, the integral is equal to 1. Clearly the function is positive. If x is between 1 and 3, x cubed is positive, 5x is positive, so clearly it's positive. The more complicated thing to check is to ensure that the integral from 1 to 3 of x cubed plus 5x over 40 is equal to 1. So we integrate this. We get 1 over 40 times x to the fourth over 4 plus 5x squared over 2, evaluated from 3 to 1. So that's equal to 1/40. Plugging in the 3, we get 81/4 plus 9 times 5 makes 45 halves, minus 1/4 plus 5 halves. And so doing the integral, we get that, doing the calculations here, 81/4 minus 1/4 is 80/4, and 80/4 is equal to 20. 45 halves minus 5 halves is 20 halves, which is 40 halves, which is also 20. And so finally we get 1. And so indeed this is a PDF. The second part of the question asks us to find, ask us to find the probability that x is greater than or equal to 2. So I integrate from 2 to 3. I stop the integral at 3 because the function only has support between 1 and 3. So the answer is going to be fairly similar to what it's on the screen currently, except I integrate not from 1 to 3, but from 2 to 3. So let me get rid of everything that's not going to be the same. So the right endpoint here is going to be different. So let me get rid of that. The 1 here is going to become a 2, and also this 1 is a 2. So let me write this a little more carefully. We have integral from 2 to 3. So I have a 2 down here. And of course the final answer changes, so let me get rid of that. So plugging in 3 again, I get 81/4 plus 45 halves. Plugging in 2, I get 16 over 4. Plus, plug in 4, I get 20 over 2. And then it's just simply a matter of simplification of this fraction. So we have 1/40. So let's do the fraction here. We have 81 divided by 4 plus 21.5, or 22.5, minus 4, and then minus 10. Then the whole thing divided by 40 gives us 0.71875. So this probability is 0.71875. So to find a probability, we integrate. The answer, of course, has to be somewhere between 0 and 1. If I get an answer that is either less than 0 or greater than 1, I know I did the problem wrong, and then I'd have to restart. Okay, the next part of the problem asks us to find the expected value of x. To get the expected value of x, that will be the integral from 1 to 3 of the PDF times an extra x. So x cubed plus 5x all divided by 40 dx. So that's equal to the integral from 1 to 3 of 1/40 times x to the fourth plus 5x squared dx. So that will be equal to 1/40. Then I plug in, or then I integrate, so x to the fifth over 5 plus 5/3 x squared, x cubed, pardon me, 5/3 x cubed, evaluated from 3 to 1. So then it's just a matter of doing the computations at this point. We have 1/40. Plugging in 3, I get 243 over 5. Plus, plug in 3 over here, I get 27 divided by 3 is 9, times 5 makes 45. Minus, then plugging in 1, I get 1/5 plus 1/3. Okay, and then it's just a matter of figuring out numerically what this works out to be. Let me do this in Excel here at the bottom. So this is equal to 1/40 times 243 over 5 plus 45 minus 1/5 plus 1/3. I get 2.326667. Now notice that it is perfectly acceptable for this number to be something that's bigger than 1. This is not a probability, it is a expected value. Probabilities must be between 0 and 1, but expected values could be something different. So that's the expected value of x. The next part of the question asks us to find the standard deviation of x. To get the standard deviation of x, the first thing that I need to compute is the expected value of x squared. So let me get rid of almost everything that we just did. And the issue is to now find the expected value of x squared. And which means I need to have a squared there when I find the integral. So that'll be the integral from 1 to 3 of 1/40 x to the fifth plus 5x cubed dx. So 1/40 x to the sixth divided by 6 plus 5x to the fourth divided by 4. And that should be just simply x to the fourth and x to the 14th. So let me get rid of that extra little smudge. And I integrate this between 3 and 1 again. So then I need to plug in numbers again. So 1/40 x to the sixth, plugging in 3, I get 729 divided by 6 plus 5 times 81 over 4 minus, then I plug in 1 to get 1/6 plus 1/4. Okay, then once again I will use Excel to do the calculation for me. So this right here was the mean. The expected value of x squared, where the 2 should be a superscript of course, will be equal to 1/40 times 729 over 6 plus 5 times 81 over 4 minus 1/6 plus 1/4, which gives me expected value of x squared of about 5.5583 bar. So that's the expected value of x squared. Now, using these two numbers, I can now get the standard deviation of standard deviation. And I do that by, let me clear out the mess here. To get the standard deviation of x, I now use the formula that the standard deviation of x is equal to the square root of the expected value of x squared minus the mean squared. So for this problem, the standard deviation of x would be equal to the square root of a2 minus a1 squared. The expected value of 5.5583 bar minus 2.326 bar, which gives me a standard deviation of 0.38. Rounding off to 3 decimal places, 0.381. So that is the standard deviation of the random variable. The next part of the problem asks us to find the cumulative distribution function. To find the cumulative distribution function, we have to integrate. Now, the good news is that part of the cumulative distribution function is quite easy. So f of x, the cumulative distribution function, equals. Now, this divides into three cases. The case where x is less than 1, the case where x is between 1 and 3, and the case where x is bigger than 3. Okay, now to do the easy cases, let's draw the picture here for between 1 and 3. Suppose little x is over here, just for the sake of argument. What is the chance that capital X is less than or equal to this little x? What's the chance that the value of capital X is somewhere over here to the left of x? Well, clearly that can't happen. Capital X must be between 1 and 3. It cannot be to the left of little x. And so the chance of that happening is 0. So the chance of that happening is 0. On the other extreme, suppose little x is over here to the far right, to the right of 3. What is the chance that the random variable is going to be to the left of little x? Well, clearly that must happen. Capital X takes values between 1 and 3. And so whatever the value is, it's going to be to the left of little x. And so the chance of that happening is going to be exactly 1. The only interesting case will be the case between 1 and 3. So let's, to do that, we need to integrate. So I need the integral from 1 to x. So if x is in the middle here, the chance that capital X is less than or equal to little x is going to be the chance of being between 1 and x. So I need to integrate between 1 and x, t cubed plus 5t divided by 40 dt. And I use the letter t because the letter x has already been reserved for the right endpoint of this integration. So when I do the integral, this will look something like the problem 1 and 2 earlier. 1/40 times t to the 4th, or over 4, plus, that's a 4, if I can draw it right, plus 5t squared divided by 2, evaluated from x to 1. And so this will be equal to 1/40 times x to the 4th over 4 plus 5x squared over 2 minus, then plugging in 1, I get 1/4 minus an extra 5 halves. So 1/4 minus 1, or 5 halves. And so that is the density function, or the CDF in the case where x is between 1 and 3. So let me copy this, and this goes right here as the answer. So that's the answer in the case that x is between 1 and 3. And of course, I probably should simplify the 1/4 minus a fourth minus 5/2 to be minus 11/4. So let me do that. Minus 11/4, and then get rid of this. So that is the cumulative distribution function. Lastly, we need to figure out the 80th percentile. The 80th percentile. So to get the 80th percentile, the question asks, find the value of x so that the area between 1 and x is equal to 0.8. So, in other words, I need to set this integral, same integral that I had before, equal to 0.8 and solve for x. In other words, I need to take this number right here, or this expression, the expression that we just found, and set that equal to 0.8. Now this is basically an exercise in algebra, which I'm not going to do on the video here because I don't think there's a whole lot of educational value in going through this every single step. But I'll get started on it at least. To do this particular example, if I multiply by 40 on both sides, we get that x to the fourth over 4 plus 5x squared over 2 minus 11/4 is equal to 40 times 0.8, which is 32. Then if I multiply by an extra 4, just to kind of clear out the denominators, I get x to the fourth plus 10x squared. Then I would get 11 minus 128, which is minus 117, equals 0. So this becomes quadratic in form, and then I can use the quadratic formula to solve for x squared. Negative 10 plus or minus, now it's clearly got to be plus because I got to take the square root in order to solve for x, of b minus 4ac divided by 2a. And then I plug into my calculator to figure out what x squared is, and then finally take the square root of that to figure out what x is. So x would be equal to whatever the square root of that expression is. So that is the way to solve for the percentile. The answer that you get better be between 1 and 3. If the answer is not between 1 and 3 for this particular example, then we know something is incorrect.